As a math major, teaching assistant, and tutor, I've heard one question more than anything else. Seriously, like, am I ever gonna really use this in my real life? After I resist the temptation to smack them upside the head and ask them a question, when are you gonna use your face in real life, punk? I sometimes find I don't really have a very good answer for them. I mean, it kind of seems like if you're not a teacher or an engineer or a scientist, you won't need to know much math other than algebra, geometry, and tax evasion. I mean, calculation. Pay your taxes, kids. Pay your taxes. So it's understandable why people would be frustrated with a difficult class that doesn't even seem to have to do with their own careers. But that's not just true in math, that's true with all the core subjects. And despite what my high school me would have said, all the core subjects are important to anyone in any field because it teaches you how to think. Later, I'll do a video for the fellow math majors. Oh, don't major in math. That's not a good thing to major in. Later, I'll make a video for my fellow math majors out there to tell them why humanities are a big deal. But for now, this is a letter to the liberal arts majors out there who think math is boring and useless. To make things more interesting, we'll discuss philosophy over some freestyle frisbee. I call it philosoph frisbee. Or should it be philosoph freestyle? I don't know. Let me know. What do you think?
As a person dedicated to math and the sciences, I always felt kind of backwards from everyone else. I mean, most of my friends whined incessantly about how they would never use pre-calculus as an RN or whatever their career was. But, I just wanted to argue that knowing Jim's attitude towards Huck Finn seemed pretty unhelpful to research in mathematics. In my mind, if you're going to bash one core topic, you might as well be fair about bashing all of them. I mean, yeah, if you're an engineer or a scientist, maybe talking about how math is the language of science or the foundation of technology is probably not the right path to tell you why this is important. Let the geeks handle that stuff, right? But that doesn't get rid of the fact that math is a language. If you don't believe it, take a look at a mathematical paper sometime. Now, if you understand what all those symbols mean and take the time to become familiar with the context, you can break down any formula into pieces and understand how it all fits together. And in a lot of ways, this language is much clearer than our day-to-day language. If someone tells me I have to invite less than 300 people to a party, does that mean I can invite exactly 300 people, or does it mean I have to have 299 or less? In math, I can say exactly what I mean by using a less than or less than an equal to sign. So when your teacher slams you for using the wrong notation, it's not because they signed a contract to ruin your life one test at a time. It's because no matter what you might have been thinking, you expressed the wrong idea. It'd be like replacing or with and while writing an answer on an English test, which could change the entire meaning of the answer. Instructors can't read your mind, so if you want the points, you better put the effort into expressing your thoughts clearly and correctly, just like anything else. Much of that effort has to do with learning and applying step-by-step processes, something that will show up in everything from putting together an IKEA bookshelf to cooking from a recipe. To continue with that culinary analogy, once you learn the basics like braising, sauteing, and pan frying, you can apply those methods to making unlimited dishes. In high school math, just about everything you learn from algebra onward is centered around giving you tools to handle calculus. Take it from me, the hardest part of calculus is almost always the algebra, and the better you get at simplifying, expanding, and rewriting things in different ways, the stronger you will be later on. Just as in life, sometimes solving a problem will have many ways to arrive at the correct solution, although some ways are definitely faster than others. Oftentimes you'll have to plow through a problem knowing that things are just going to look worse and worse before it gets any better. Other times, you may have to see your mistake and be willing to start over with a completely new plan. If any of this sounds familiar, it's because it's life. There are problems everywhere, and the patience and skill you gain from solving a dinky little quiz question can help you deal with the big stuff when crap gets real. That's because math isn't numbers and equations. It's a way of thinking. Contrary to what happens in classrooms, people like Euclid and Archimedes weren't just handed a book with all the laws of mathematics in it. For every single symbol, operation, and concept of mathematics, someone, or a group of someones usually, had to invent it. A person had to say, hey, this straight line represents the number 1, which has the quantity of a single object. Someone had to say that addition means combining the values of two numbers. Another said that multiplication is like adding something to itself a bunch of times. And eventually somebody mentioned that multiplying a number by itself lots of times should have its own notation as well. But you can't just go around making up any rule you want. It has to fit with all the other rules we agreed upon earlier, like a giant game of tag where you keep making up new rules, but you can't break the old ones. The reason you can't divide by 0 is that it contradicts some laws of mathematics we already agreed upon, no matter what we do. Theoretically, dividing by smaller and smaller numbers gives us big numbers, so dividing by 0 should give us infinity. But since multiplication and division are inverses, that means 0 times infinity would equal 1, and 2, and pi to the e squared plus phi. Basically, it would equal every conceivable number. That doesn't fit with the logic we set up, so we have to throw it out. Which brings us back to real life. Sometimes ideas in our own logic conflict, and we have to decide which ones make the most sense, and which ones to throw out. Math teaches us to see right and wrong answers, when they're available at least, and make the decision we think is most correct. And as we add more and more information and rules to our mental toolkit, we evaluate what we know, decide if the new information is worth keeping, and sometimes even replace older ideas with what we've discovered. And that's how analysis of all kinds can intersect, whether it's in a math classroom or an English classroom or in daily life. Humanities can help us find the flaws and capabilities within ourselves, and mathematics can teach us how to absorb that information and assimilate it into our individual logic of self and morality. And you said math was boring. Take care.